So, hi everyone, I am Arda Unalan from 11th grade as an electrics and electronics student. I'll be making two videos for you, and in these two videos, I'll be talking about what is PLC, where to use PLC, how to code a PLC, also how to, for example, upload a code to a PLC, and the components about the coding part about PLC. So mainly you'll just understand the basics of the PLC, and hopefully by the end of these two lessons, at least you'll have this some idea of how to use a PLC in your projects. By the way, if you have any questions about PLC, you can just come find me at the school and just ask whenever you want. I'll be free for you. So let's start. You can see this is a PLC. You may think it is just a simple box. It's approximately like this. And what PLC does is just simple. Let's just imagine a factory. For example, inside that factory, we have conveyor rails or just machines. For example, a machine just takes this pen and takes it up to here. And it's for example, a pen factory. To code those machines, to tell those machines to take them from here to here, we need some translators. You can imagine it like that, some translator. And PLC is the translator for us. By using PLC, we can control machines, or for example, rails or the systems, like that by coding the PLC. So PLC is the translator of the machine and the code. Uh, and to code what PLC does, I just told you. You can see, let's check the PLC. First, to make the PLC start, we need to give a 24 voltage and also a ground to give the energy to the PLC. First, I'll add this part. When we write code from our computer, we will be writing in the future time. To upload that code from our computer to the PLC, we need to find an Ethernet cable. Think it like we got two tips of it. We just want to take one tip and then plug it into our computer, and the other tip of the Ethernet, we just plug it into, you can see this Ethernet PC link socket. By connecting them and making the right steps, we will be able to upload our code from our computer to the PLC. So this Ethernet port does that job. These are some ports for other modules. You don't need to know them in this beginning level. You can see here are some outputs. For example, if I want to control something, these are the outputs. If I want to control something, I'll be doing this with the outputs. For example, I can say PLC that if this situation is happened, make this machine move. So to understand that situation had happened, I'll check the inputs, and to make that machine move, I'll use the outputs. You will understand when I'll be doing some exercises about the coding parts. So let's just move on. If you got that PLC part, let's see how the coding system works, and let's continue. So I'm using GMT Suite, the latest version. Be careful while you are downloading the GMT Suite. You should download the latest version to make it work better with the PLC. By the way, I forgot to add that there are many various of companies in the sector about PLC. For example, also Siemens does some PLCs and other kind of companies. But in school we have GMT PLCs, so also we'll be using their coding system. Not, for example, this coding system won't be working in a Siemens labeled PLC. This is specialized for GMT versions, and also this is a version PLC, as you can see from here. So let's continue. This is the coding program. When we came to the coding program, we can see an empty space. To open a new project, we just click on this new button. And by click on that, we can create a new project. We can give whatever name we want. And after that, we just click save and the project will be opened. I've opened a new project just a few seconds ago before I start the video. So I'll be continuing from there. Also, if we have any projects that we have opened before, we can just click on this open and find that project and open it. So the system should be looking like this, and at this lesson I'll be teaching. You can see here are some components. These are our component window. These are the blocks that we'll be using to code our PLC. You can see I'll tell the basics of these ones. There are a lot of them, but for the beginning level, you just need to know maybe 5 or 10 of them. So I guess it would be enough for you to have an idea about PLC. So first let's check the system and I'll tell how to upload our code from computer to the PLC first of all. When we open the system, before we come to this page, you will see a page like this. And that page just basically stands for our PLC's version. For example, if I'm using an GLC 496R type PLC, I just click on that and just click on that plus button. And as you can see, it's saying you have already added it because that's you can see here. For example, if I want to delete the PLC, I'll just click on it and click on this cancel button, the cross, and I can delete the PLC. You'll see something like this and just come here, choose your type of PLC. For example, it could be 396T. In school, we mostly use 496R, so I'll just add that. You can see you can add PLC like this. Also, we got some extra modules here. For example, we got 20UA. You can see it here. If I just click on that and edit, we can also work on this 20UA model too. So if you are going to work on some models of the PLC, like the main PLC, hold it somewhere else and just add the new models of the PLC to that. This could be one of them. So you can just edit like them. And if you want to delete them, as I said you before, you can just click on this and click on that cross. And so it will get deleted. And by adding our PLC, we can start our coding part. I also said before that before the part, the details about how to upload our code from our computer to the PLC. So let's check them. You can see at here we got a panel like this. When we click on that, we will see something like this. When we put our Ethernet cables, one tip to our computer and the other tip to our PLC will show up here like this. I don't know if you can see, but it'll show up like this. And after that, we will just mostly all the PLC's passcode is the same 1, 2, 3, 4, and we'll just click to the connect, and our PLC will be connected with our computer, but our job hasn't done yet. First of all, we have connected our PLC with our computer, and then we quit here. And to upload our code, you can see there is a button like this. We will click on that. And because right now I'm not connected to a PLC, it may show in active mode, but when you connect to a PLC, this will get its color and it will show more like it's active. So you will just click on this one. What this button makes, it just takes the code, takes the program from our computer to the PLC by the Ethernet cable. And to start the code at the PLC, you'll just click on this link, kind of like the link button. It's just similar to a link button. That's why I said like that. So these two buttons will do our job. And after that, we can just click on that again, and our code will be uploaded and will be started by like working at our PLC. Let's check these panels. For example, to add a new when our projects could get in a mess. For example, sometimes they could be in for example 50 stairs, maybe I can say that. Like we say at the ladder program, ladder team here. To save our to save our code before we close, we can just click on that. And sometimes we may want to start our code, like kind of test our code, but we shouldn't have been uploading them to the PLC. In those situations, I'll be showing, I don't know if it will work because my computer has a problem, but at those situations, like we may call it as an offline simulator. This button will do our job. It will work as an offline simulator, and so by this way, if you don't have any PLC, you'll be able to try out your code without uploading them to the PLC. So this is basically the panel. Also, I want you to know that when we are doing coding at here, we are using operands. What are the operands? For example, we are using a timer. For that timer, we will be using some values for each output. And those values should be contained in somewhere, and we call them as operands. When I, for example, I'll be making a start button. I'll just put a button up there and write the value of that button as start. So my start operand will be added here, and I can see all those operands I can use in here. Like the names I'm using at my code are listed at here. So let's continue if you understand the operand system. So this is our ladder program, and we will be adding these blocks, these code blocks to code our PLC. I'll just drag it like this, so maybe you can see them better. I hope you see them better. So let's start. Again, I'm telling you that I'll tell the basics about those code blocks. There are various and plenty of those code blocks, but I won't be able to tell them all. For that, you can see there is a question button up here. If you click on that, let's try out. If you click on that, the GMT will give a handbook. We can call it as a handbook, and it will help all the details about those code blocks, and it's basically, yeah, just a handbook to how to use the GMT suite programmer. You may also could find help from this question button, but now you'll be listening from me the basics of the code blocks. So let's start. For example, if let's start with this one. We can use this, as I told you, that outputs. If electricity comes to this one, the when we start this its one's value will be 0. But when the electricity will reach to this component, we will call it as a direct output. It will turn into 1. So we may use them as virtual or in real life. For example, if I write here CPU, you can see these are the IP ones. If I want to get an information from outside inside of my PLC, I will use these IP ones. But mostly we don't use IP as the direct outputs. We mostly use them as the contacts. At the direct outputs, we generally use these ones, the QP ones. What are the QP ones? There are the outputs. I told you in that PLC, here are the outputs. If I want to control a machine, I will need some outputs. And so by writing the output's name, for example, you can see there is an output, let's say the one, CPU QP1, it will be mentioned like that. And by writing that, I'll be able to control that output. How I control it, for example, I'll just tell the program to make it a 1 instead of 0, and in the PLC it will turn into something like that. The 1, if I connect any cable to the 1, the 24 voltages will come out from the 1, so I'll get the voltage I want from the output that I want. So this also we can use them as virtual relays. Yeah, in the relay system. So the output system is like that. I can just name them. By the way, I'm repeating again. I'll just tell the components to you. I won't be making any system at the first video right now, because my computer could get in some different weird situations, and maybe sometimes it won't work while recording it. So I'll just tell the component, just hear me out and don't expect me to just make a circuit. I'll be making a circuit in the next video, and we will be searching for the components to make that circuit in the next video. So let's check. You maybe understand, this is the line that electricity comes from, and these are the electricity outputs. You can think like that. For example, if I want to control that, like when I press the button, the electricity should pass, and when I take my hand off the button, or when I press again to the button, the electricity wouldn't come, shouldn't come. So I'll just use this one. What this one makes is that you can see it's a normally open contact. And when I press on that, it will close in itself and let the electricity pass from here. As the with the same meaning, with the similar meaning of that, we have this one, and this is the normally closed. So when the system first starts, it will be closed. This means the electricity would pass from here. But when I click on that as a button, the electricity couldn't be able to pass from here because this one will be open. So when we see something like that, we should think this is the zero location. When I click on, it will be the one connection, and the one connection will be opposite of that. If it's open, it will get closed, and if it's closed, it will be getting opened. And let's continue. For example, think the electricity as many of you can, like there are one electric, one electric, one electric, and they become the electricity. In this situation, if electricity would stop coming to this direct output, this direct output will be turned from 1 instead of will be turning 0 instead of 1. But if we don't want this kind of situation, like if we just want to, when I click on that, whether I take my hand off the button, whether the electricity would pass off, I want to keep the voltage at the output, I can use this one, the set one. The difference, this and this, I just told you, if the electricity would come this just only for once and the electricity would gone off, it will keep working. And you may think, how could I stop it? Like, I know it's working, but I need to stop that. And for that, you see, we got that reset. And when the reset gets the electricity, this will get resetted. Don't think this as an output. This is the resetter of this output. These are our outputs that we will be using. So let's go on. You can see here is the mathematics part. I told you that we will be using operands, and by this equalize function, we can equalize two opponents with them. For example, I got a counter opponent and I got a value that is 5, and I want to just make that counter value set to 5. I can be use this, like I'll just click and type here the value, like the timer, and after that I'll be writing here 5. So when this gets electricity, the equalization will be done, and the top operand and the bottom operand will be the same thing. Also, you can see there is add 1 and minus 1. Basically what they do, we will be typing values on top of them, and when the electricity comes to them, they are adding 1 to the value that you have added before. Also, we got these ones. These, I told you that we are using operands, and for example, there is operand A, which is 5, and there is operand B, which is 10. And when this function gets the electricity, it just adds the operands on top of them and gives me a new value, which you can see and use it in the other sides of your circuit. And the others are the same meaning. You can so understand them like the divide or minus function. And let's go on from here. We got these ones. I'll just tell you one sentence, and if you get that sentence, you'll just understand all these types, how to use them. The main thing about using these are if the top value is equalized to the bottom value, pass the electricity. Don't think that these are all are the equalizers. For example, if the top value, this one, is bigger, the middle symbol, symbol, is the top value is bigger than the bottom value, pass the electricity. For example, if the top value is 5 and the bottom value uh, is 10. So 5 isn't bigger than 10, so electricity wouldn't pass. But if the top value is 5 and the bottom value is 2, 5 is bigger than 2, so this will be turned on and electricity could pass. So these are the contacts that work manually without my permission. By the permission is the symbol between them. And let's go on. Let me tell the details about time relay. And after this one, I will be telling you one component, and the first lesson will be end. Will be reaching the end, and after that, we'll make a new circuit in the second video. So the timer works like that. I told you there are outputs. This timer is also the name of the timer and the output of the timer. This could be only 1 and 0. Don't forget that outputs can only be 1 and 0. And we are basically using 1 and zeros everywhere in the computer world. So this will help us while we will be programming machines. You can see it says me the time. It's the For example, if I write here 10 and I start the timer after 10 seconds, this timer, the name, the output will be turned into 1 instead of 0 because the goal will be reached. You can think like that. And this is the counter. For example, if we will be doing some mathematics or in the previous circuits, we will be need to change the value according to the time we are counting. We will be using this value of that. Like this is 10, but we need to see that it's counting to 10. 1, 2, 3, 4, 5. We can look up to this value by saying it's 1, 2, 3, 4, 5, and goes like that. And this is if the timer will go by seconds, milliseconds, or minutes, we can adjust it from there. And this value is, for example, when we start an offline simulator, if the simulator ends, the time could be 5 seconds, but it hasn't reached the 10 seconds, it's 5 seconds. But when we close the program, it will restart. But if we put this as don't restart mode, like you can see it's get restarted or don't restart, it will change its function according to those managements. Mostly we use restart, this one. You can use that also. And let's go on with the last component that I'll be teaching you, the counter. So what the counter does is basically, let's check it out. This value is, again, I'm telling you the output of the counter. If this value equals to this value will be turned into 1 instead of 0 and give me an output of 24 voltage to use maybe in my circuit or in real life to control some machines. So as I told you before, think it like in the timer, this is the counting thing inside of it, and this is the goal. If the counter reached to the goal, it will give me an output. And if this function gets 1 instead of 0, we can make that 1 by using these ones. the whole timer will be resetted. Like if the counter is at 6 and if the goal is 10, but we want to reset the timer and start the whole thing again, we can just use this function by adding these ones and restart the timer. And this is the quantity of how the timer will add on itself. Like it can go 1 plus 1 plus 1 plus, or it can go 2, 4, 6, 8, or it can go 5, 10, 15, 20, and like that. So this will give us the amount of the adding. And so these are the components that you should be knowing to understand the next circuit I will be teaching you to do. And I can tell that that circuit will be, I guess we can do a traffic light. For example, we can make that traffic light count to 15 seconds, and according to those 15 seconds, for example, first second and 15 second between fifth second between those seconds, let the green light be on. We can make a circuit like that. So see you on the next video.